The design of cylinder cover. Cylinder in the sense, it is the cylinder of an IC engine, internal combustion engine. So this is typically the diagram of an internal combustion engine. So as all of you know that, so this is the cylindrical block in which there is a cylindrical hole, and in that hole the piston reciprocates between TDC to BDC, right? And this is the cap of the cylinder. This is the cap or cylinder head. It is also called as cylinder head or also called as cylinder cover. Okay, so this is used to cover or to close the hole, the cylindrical hole made in the cylindrical block, so that the combustion gases will not escape outside. Right, now this cap has to be screwed to the cylinder block in order to ensure proper sealing of the combustion chamber. Okay, see here, this cylinder block is provided with some flange like thing. Here, if you observe, it is provided with some flange like thing. Okay, so the cylinder will be there like this, on which a flange will be there, and on that flange this cap is also of cylindrical shape, for example. Okay, so on this cylindrical flange this cap is placed, and there are certain number of holes. So here I have shown 4 holes are made both on the cylindrical block flange as well as on this cap, and all the holes are aligned properly together. That means the hole in the cover and the hole in the cylindrical block flange, both are properly aligned. And if you observe here in the cylindrical block, the hole is not completely made. It is not a through hole. Instead, hole is drilled up to certain depth only. So that is called as blind hole. So it is basically a blind hole. But in case of cover, it is a through hole. From top to bottom, there will be a hole. And here, in order to join these two things, we use a separate type of bolts called as studs. What is the name of that bolt? Studs. So stud is also a type of bolt in which there is no head. Head undadu. Instead of that, it consists of threaded portions on both the ends. So it is like this. If this is the stud, okay, so it consists of threaded portions on both the ends, like this. Our usual bolt consists of threaded portion on one end on the shank, and at the other end we have the head, but there is no head for the stud, and the threaded threads will be there on both sides of the shank. That's all. And now, in order to join these two things, first of all, this stud has to be inserted into the holes of the flange in the cylindrical block. Holes of the flange in the cylindrical block. So first, these studs have to be inserted like this. Okay. Once all the studs are fixed firmly, they are screwed firmly, then this cap is inserted through the studs in such a way that the holes are properly aligned. Like this, the cap is inserted, so that these studs will project through the holes of the cap outwards. Did you get my point? See, initially this is our cylinder. It consists of hole, and this is the stud, for example. So the stud is inserted into it. Okay, right. Now this is the cylinder cover, and it consists of also a hole. Say for example, this is the cylinder cover. It consists of hole. So that is inserted like this. Now there is some extended portion on which a nut is inserted. So like this. So this is the cylindrical block, and this is the cap, cylinder head. Okay, both are joined with the help of the stud, and on the top a nut is inserted like this. Is it clear? So like that, there may be number of bolts. Here only I have shown 4 bolts, 4 studs. There may be number of studs. Okay, like this joint is made. Now, let us discuss what are the possible stresses that may be developed in these studs. So, before going to discuss about the stresses, let us see what are the different forces acting on the studs. See, what happens inside the engine? Tell me. What happens inside the engine? Combustion takes place, so that the flue gases, the combustion gases, will exert force on the piston. Is it right or not? It not only exert force on the piston but also on the head also. So, the force is acted in all the directions like this. Since the piston is freely movable, due to the force the piston moves downwards. But here, this head is not movable, it is firmly fixed. Even though the force will act on the head. So, this force will try to remove the head. It will try to move the head upwards. But these studs will prevent its movement. Due to which, some force is assumed to be acting on the studs. So, which type of force is that? Is it tensile or shear or compressive? Here, this is the joint. Okay, due to the force, both are trying to be separated. But this bolt is resisting, this stud is resisting. So, which type of force? It is obviously tensile force. Okay, see, this is try to move upwards like this. But the stud is resisting the force. So, that's why the tensile force is acted upon it like this in all the 4 bolts. So, whatever be the force which is developed inside this is distributed to all the bolts. So, first of all, let us calculate what is the load, what is the force acting on the 4 bolts. Okay, we know that the general formula is P is equal to stress is equal to load by area. Is it right or not? So, if you want force, P is equal to stress into area, where stress is the tensile stress. Is it right or not? Okay. If there are n number, this is for one bolt. If there are n number of bolts, then this will become sigma T into n into where it is pi by 4 dc square. Since it is tensile force, pi by 4 dc square. Now, how do you get this force? This force is due to the combustion gases. This force is due to the combustion gases. So, let us call this force. Let me call this as W, not P. Let the force be W. Okay, or F. W ante weight antam kada manam. So, let me call this as F. P and endukantladante P ippudu manam vaadtam. Right. Now, what is the force acting inside this? So, you will be given with the pressure which is acting inside the combustion chamber. So, this pressure is responsible for the force. Is it right or not? The combustion gases are having very high pressure. And we know that force is equal to pressure into area. Force is equal to pressure into area. So, pressure is the pressure acting inside the cylinder due to the combustion gases, due to the process of combustion. Okay, and area means here this area. See, this is a cylindrical hole. Is it right or not? This is a cylindrical hole. So, this area multiplied by that pressure will give us the force. So, that's why the pressure is P, and what is this area? See, its diameter is D. So, this is pi by 4 d square. So, this is the force acting on the head, which is distributed to the bolts, all the studs. So, both are equal. Am I right or not? This force and this force are equal. So, that's why P into pi by 4 d square is equal to sigma T into n into pi by 4 dc square. So, by using this relation, you can get the value of core diameter of one stud. Okay. So, if core diameter is available, then D is equal to dc by 0.84. So that you can get the value of D. Okay, so our aim is to design a cylinder cover joint, not only a single bolt. So for the purpose, you have to determine all the dimensions. See, if you observe, the dimension says here this is DP. See, all the bolts are arranged in a circular form. Okay, so this circle, along the circle only all the studs are arranged. So that circle is called as pitch circle, and DP is the pitch circle diameter. Chusara? This DP is the pitch circle diameter. So DP is equal to pitch circle dia. So which is given by capital D plus 3D plus 2T. Capital D means diameter of the cylinder here. D is diameter of the stud, what we got. And T is the thickness of the cylinder cover, it will be given. Sorry, thickness of the cylinder. Okay, so this is for pitch circle diameter, and for outer diameter also there is a formula. DO is equal to DP. DP means pitch circle diameter plus 3D. DP plus 3D. Okay, right. So you have to determine these two things. Once if you get the value of D, you can determine the pitch circle diameter of the cylinder. Okay, and the outer diameter of the cylinder head. So these things are to be determined for designing the cylinder covers.